Hi, this is Mr. Anderson giving you a brief lesson on the Pythagorean theorem. We started looking at the Pythagorean theorem on Monday, where we just reminded you of the theorem that you probably remember from middle school. That is that the sum of the squares of the two sides are equal to the square of the hypotenuse. So the hypotenuse squared equals the sum of the two legs squared, which usually books and mathematicians write as c squared equals a squared plus b squared. So if we take this triangle here, I just want to check that the Pythagorean theorem works. So across from this 90-degree angle is the hypotenuse, which happens to be the longest side. This is always the case. So I'm going to plug that into the formula that 5 squared equals the two legs squared, a and b. Doesn't matter which one is a and which one is b. So 4 squared plus 3 squared. 5 squared is 5 times 5, which is 25. 4 squared is 4 times 4, that's 16, plus 3 squared, which is 3 times 3, which is 9. And sure enough, if I add 16 plus 9, I get 25. It worked, exactly what we wanted to have. I just want to give you a geometric argument to why this works. Let's take this triangle, and I'm going to turn the sides into literal squares. If I take the length 5 here and put the length of 5 here, what I get is I'm going to get a square that's 5 by 5. So if I multiply this 5 by this 5 to find the area of this square, I find that it's 25, the same way that I found in the theorem. I also have the 3 squared, which is here, which is now a 3 by 3, so we get 9 squares. And I'm going to do the 4 by 4, and there's a reason why I have this cut up, and you'll see in a moment, but I will still get the 4 squares by 4 squares, which is a total of 16 squares. I can count these squares and these squares to see that they're the same number as here. But what I can do is actually overlay them and put these here to see that the two leg squares are exactly the same as the hypotenuse square. This is sort of a geometric argument for why the Pythagorean theorem works. Turns out that this only works for right triangles, which is what makes it so special. There are a lot of triangles, like this triangle, which is an obtuse triangle, and it's not a right triangle. If I try to turn these sides into squares, like so, that this is a 6-sided square, so that's an area of 36, and I kept the other lengths the same as 3 squared and 4 squared, if I try to match up the areas here, you're going to find that I do not have enough squares to make this work. The Pythagorean theorem is not true. That's because this was an obtuse triangle. In fact, the sum of the two legs is actually less than the sum of the hypotenuse. If I take an acute triangle, where all of the angles are less than 90 degrees, and try to do the same thing as before by turning the sides into squares and trying to match up their areas, I'm going to find that it doesn't work. Because here, if I match this up on this side, I have this extra area left over. It turns out that the sum of the two legs is now greater than the area of the hypotenuse. It doesn't work. So taking this information, we can actually prove a triangle is a right triangle. This triangle here certainly looks right, but there's no guarantee that it is. Perhaps whoever drew this triangle was just a bad drawer. So all that I need to do is just test these sides using the Pythagorean theorem, and if it gives me a true statement, I've done it. I've proven that this triangle is right. So the longest side is going to be your hypotenuse, or your C, and the other lengths are your A and your B. If I plug that into the formula and check that it works, we should know if this is a right triangle or not. So C squared is 97, A squared is 65, b is then 72 squared. 97 squared is 9,409. 65 squared is 4,225. And 72 squared is 5,184. And yes, I use a calculator to find these values. And if I add these two values together, I find that they are equal to 9,409. So it works. These values give me a right triangle. So this was true. This is a right triangle. This right here is a 90-degree angle. Let's try the next one. So I'm going to do the same thing. The longest side becomes my hypotenuse, and I have the other a and b sides. So c squared equals a squared plus b squared. I'm going to plug in my values. So that's 26 squared equals 22 squared plus 14 squared. 26 squared is 676 equals, well, 22 squared is 484, and 14 squared, which is 196. And I add those two values together, and I find that this is 680. These are not equal to each other. This is not a right triangle. This right here is not 90 degrees. Why? Because the Pythagorean theorem did not give me a true statement. So if you plug in the values for a triangle, you're going to be able to show, using the Pythagorean theorem, whether or not a triangle is right or not. For today's assignment, we just have a brief applet for you to try. When you're finished with it and you see the completion screen, please take a picture of it and upload it to Google Classroom. If you have any questions, we all have office hours, so please feel free to stop by. Thank you.